So for our next topic, we have work or energy in spring. So we'll be utilizing here the Hooke's law. So F is equal to Kx, where F is the force and X is the displacement, and K will be your um, spring constant or modulus. Okay. So you'll have here, if you take the integral of both sides, so du equal to f dx, and then you eventually have here u is equal to 1 half kx squared, or also equal to replacing the kx here with f, 1 half fx. Okay? So k here will be the spring constant or the modulus, x will be the displacement of stretch spring, and force will be the f, and u will be the work done. So with that, let's get into the next problem. So we have here for number 1, so a spring have a modulus. So we already have a given here. So a spring having a modulus of 8.8 Newton per millimeter. So we have here K is equal to 8.8 Newton per millimeter. Has a natural length of 250 millimeter. Work equal to 90,000 Newton millimeter is exerted in pulling it from a length of 300 millimeter to a length L. Okay? And then find the length L. Okay, so we have here a couple of things. So first, we have the natural length 250 meters, 250 millimeter. So let's just say that this is 250 millimeter from here. Okay. Let's say that this is the natural length. Okay, that's the natural length of the spring. Right. So 250. This is actually 250 million. I can just not write the unit anymore so that it will save some space. So let's say that this is 250. Okay, 250. And then we also have 300 millimeters. Okay. So let's just say that this is 300. Okay. No, this is not actually 300. This must be only 50. Okay, 50. So that's 250, and then 250, of course, this will be 300, right? 300. And then we have here length L. So we have a length L. So let's say that extending this one, so we have here a length L. So L. So we don't know the length L. There you go. Okay, so we have to find the length L. And then we have here a 90,000. So 90,000 is exerted in pulling it from a length 300 to length L. 300 to length L. Therefore, we can say that your U here from 300, okay, 300 to L, we have this is the U or the energy that you have to exert from pulling it from 300 to the length L. Okay? So with that, I think we can, of course, you will have here also a U here. Okay? You will also have a U here, which is from 250 to, this is 252. Okay. This is 250 to 300. Okay? No, no. So this should be not here. It should be only here. Okay? So you'll also have here U to 250 to 300. Okay? There you go. Therefore, you will also have here the U will also have from here, this will be the to here. This will be your U from 250 to L. So we can, as you can see, you can have here um by energy balancing. By energy balancing, as you can see that we have here a this one. Okay, that's U 250 to 300 and then 300 and then 300 to L, and then we also have this. Therefore, we can simply say, okay, we can simply say that your U or your work done from 250 to L. This is simply, we can just simply separate this into two parts. This is your U from 250 to 300 plus your U from 300 to L. So, using the formula, we have here 1 half K, okay, Kx squared. I can just put the values directly now. So, you'll have here, your K is 8.8, right? So, you will have your 8.8. And then, times X is the displacement, okay? So, you'll have here from L to minus 250. So, that will be your displacement for the first one, squared, equal to 1 half 8.8. Again, that will be your K. That's what I'm using. The formula that I'm using is 1 half Kx squared. So 1 half 8.8 times, again, the displacement. So that will be 300 minus 250 squared plus 1 half 8.8 again times L minus 300. And don't forget and then, as you can see, you only have one missing, which is the L. And then you can simply now use the calcu, or you can just use no, actually we already have a value here, right? We already have a value here, actually. You don't need to use to find this one. The value for U 300L is 90,000. Okay, so for U to 300L, that is 90,000. So this should be just 90,000. That's good. I think that's good. Okay. So if you will use your calcu, the L that you will find is 401.5 million. So that's the answer.